If you zoom in on this specific region of Australia on Google Maps, you'll spot some strange markings on the ground. They were made by NASA in the 1960s for a very specific purpose. They were essentially a giant eye exam for astronauts. In the early days of the space race, the first American astronauts reported being able to see surprisingly small details on Earth from orbit. Things like villages, roads, ships, and buildings. And one report in particular caught everyone's attention. While orbiting Earth at about 160 kilometers in altitude during the Mercury Atlas 9 mission, which launched on May 15, 1963, Gordon Cooper said he could see the smoke trails of trains traveling along railroad tracks. On another occasion, while flying over the Tibet region, he claimed he could make out the silhouettes of individual houses against the snow, and even smoke rising from their chimneys. When scientists heard this, many were extremely skeptical. Some argued it was just atmospheric effects, or even that the astronaut was hallucinating. In an interview with the New York Times after a conference in Warsaw, one scientist said the report could only be a case of impaired judgment. As an experienced pilot, Major Cooper should have known it was impossible to see houses from that distance, especially since snow wouldn't provide enough contrast. But Gordon Cooper stood his ground. He said, "I don't think you could see people or anything that small, but I could definitely see smoke trails and even individual houses that were farther apart." To settle the debate, a detailed analysis of Cooper's reports was conducted. Scientists gathered data about the sightings and calculated the probabilities of him actually seeing what he described under those visibility conditions. Cooper had exceptionally sharp vision and was trained to detect small details at long distances. When they factored in lighting, contrast, atmospheric clarity, and viewing geometry, the conclusion was clear. It was entirely plausible that he really did see those things. They weren't proving he saw them, just that it wasn't impossible. This debate reinforced something NASA already knew. They needed to quantify astronauts' visual capabilities. That was especially important at that stage of the U.S. space program. Cooper's mission was the final flight of Project Mercury. The next major step was Project Gemini, designed to develop the techniques and operational know-how required for Apollo to eventually put humans on the moon. And running an experiment to test astronaut visual acuity was exactly the kind of research that fit into the Gemini roadmap. So NASA and the U.S. Navy jointly developed what became known as the Visual Acuity Experiment. Conducted during two long-duration missions, Gemini 5, which lasted 7 days, and Gemini 7, which lasted 14. The experiment had two parts. The first involved a device called the In-Flight Vision Tester. It looked like a pair of binoculars and contained a rotating disc with 36 rectangles of varying sizes and orientations etched inside. At least once a day, astronauts would position the device against their faces. It even had a dental mold to ensure perfect alignment and observe a sequence of rectangles. They would determine the orientation of each one and press a button on the back to record their answers. The responses were logged by punching data into special cards inserted into a slot in the unit. The system was manually operated, but the illumination for the rectangles came from internal lamps powered directly by the Gemini spacecraft. By tallying the punched card data in a specific way, the results could be radioed down to mission control. Those in-flight results were later compared with pre-flight baseline measurements to check for any degradation in vision. The outcome was consistent for both missions. Astronaut visual performance remained unchanged, even after weeks in space. The second part of the experiment involved ground targets. Two locations were selected, one in Texas, north of the city of Laredo, and another on a sheep station in a remote region of Western Australia. The idea was to create a massive optometry test chart on Earth's surface, visible from orbit. But pulling that off was more complicated than it sounds. In Australia, 16 squares, each 600 meters wide, were laid out in 2 rows of 8. Inside them, large white rectangles of different lengths were arranged vertically, horizontally, and diagonally, using massive quantities of white seashells transported from the coast. In the upper left corner, a special marker indicated the northwest corner of the formation, and to help astronauts locate the site among the surrounding terrain, a smoke generator was installed nearby. The goal wasn't to test whether astronauts could find the site, it was to determine whether they could correctly identify the orientation of the shapes once they were lined up on it. The Texas setup was similar, but instead of 16 squares, it had 12. These tests weren't just about checking eyesight. Scientists also used the data to correlate visual performance with atmospheric optics, ground contrast, and even light scattering caused by the Gemini spacecraft's windows. Photometers were deployed both on the ground and on board the spacecraft to quantify these factors. The objective was to build predictive models for the limits of unaided human observation from orbit, essentially to determine how much future crews could realistically see with the naked eye. Ironically, even though the Australian markings are the ones that survive to this day, no successful observations were made there during the actual missions. During Gemini 5, spacecraft attitude control issues prevented precise orientation, which was critical for the experiment. Pete Conrad did spot the smoke plume marking the site, but couldn't read the targets. And during Gemini 7, orbital adjustments caused most passes over Australia to occur at night, making visual observation impossible. The only successful observations came from the Texas targets. On Gemini 5, during Orbit 48, Conrad managed a brief look and correctly identified several of the rectangle's orientations. On Gemini 7, Frank Borman successfully observed the Laredo site twice during orbits 17 and 31 and performed very close to expected visual thresholds. In the end, the Gemini 5 and 7 visual acuity experiment confirmed that the same visual assessment techniques used for high-performance pilots on Earth could be applied to astronaut mission planning and orbital operations. And because of the unique environmental conditions in that remote part of Australia, the ground markings are still there today. If you plug in the coordinates on Google Maps, you can still see them from space. That's it for now. See you next time.